In trading, knowledge is power, and lack of knowledge in what you're doing can be costly, very costly. So you need a solid foundation of quality market education. Whether you're new to trading or a seasoned veteran looking to add advanced strategies to your arsenal, there's always something to learn and something to improve on. And now you can access the same knowledge that professional traders receive with Market Rebellion's Trading Education. I'm Bill Johnson, Head of Options Education here at Market Rebellion, and we've assembled a comprehensive curriculum based on decades of real trading experience, covering everything you need to know about trading options from beginner to advanced. We go way beyond the nuts and bolts of options theory to teach you how to apply specific trading strategies and the techniques needed to adapt your trades when markets shift. Regardless of your goals, you'll gain access to the education you need with easy-to-consume lessons so you can learn to trade with confidence, enhance your knowledge, and master the practical skills required for market success. So please join us for in-depth trading education only from Market Rebellion. Hey, good afternoon, Market Rebels, and to all of our options traders, and happy Thursday to everyone.
Yeah.
And we have a very cool topic, and I know it's probably going to push against a lot of your beliefs, but here's our topic. Chalk Talk, options decay faster near expiration. Now, we're not saying that this is true or not true. We're just going to state it as a fact because that's what options traders say. We're going to start off with this premise. And therefore, you must be careful of holding options near expiration. Is this true or false?
Which means what? You got to hedge
You got it
off,
right. Hey, I bought a 6-month option. It's down to 30 days. Let me roll it out so I don't get too close to expiration. Exactly.
Or let me buy a longer term, and then because I bought a longer term, I have to sell shorter term. And
Exactly.
all that kind of stuff.
All those different conversations fall under this umbrella. So that's what we want you to think about. What is it that you believe? What is it that you've heard? Okay, and we're going to come back and show you from a professional trader's view the way that it should be looked at, and we'll come back and answer this at the end. Now, I'm going to give you a little different plug. Normally, we don't like doing plugs, but we are super excited. So we finally got the green light for Coach's Corner Live.
Yes,
we're going to be doing
Coach's
this
Corner
for
Live.
2 straight days.
2 days.
In San Antonio. It'll be July 24th and 25th.
Riverwalk.
And we're going to be doing topics just like this. In fact, this is an excerpt from one of the presentations, and we're going to be doing this on this show here up through that date. We're going to be giving you little sound bites of what we're going to be talking about. But they're all ideas that really go against what most traders believe. We're going to show you mathematically why they don't work. Not an opinion. We're going to do live demonstrations. So if you'd like to join us for that, here's a shot of Market. Just go to marketrebellion.com, and right there, right on the front page, Coach's Corner. There it is, Stu. Did you ever think we'd see it? Coach's Corner Live Roadshow. Click on it.
I had faith. I did get the faith. Yes,
yep.
I did.
You did. So here we go. Obviously, I think that's a dead giveaway for our topic. Do options decay faster near expiration? Now, I will tell you, if you talk to, I'm going to go out on a limb here and say 100% of, 99.9% of traders, certainly all the YouTube crowd, the retail crowd, you're going to hear an overwhelming, of course they do. Why are we even asking the question? So that's our topic here. And let's start off with the first one. Is theta even a risk? All right, this is why people say this whole idea of it melting away is a huge risk. I've got to sell against it. I've got to get out. I have to do a calendar spread. I have to do something to hedge theta. Well, remember that risk is always about uncertainty. Time is certain, and that should be a clue right there. So in 30 days, a 30-day option will expire. perfect prediction. In fact, Stu, we can go right through that option chain and we can perfectly predict how long it will take for those options to expire. Anybody can do it, right?
Yeah,
Roscoe can do it.
yeah,
So
yeah,
what does that
yes,
tell
we
you?
can. Yeah.
Yeah, so if you can do that with, think about it, perfect accuracy, how does that fall under the definition of a risk? So the way that professional traders see it is that theta is really, it's just a trait or a characteristic. It just is. It's not a risk. Yes, it is a condition or a characteristic, but we're going to find out why it's there.
It's something that happens
It's something that has to happen.
as part of the DNA
It's
of
part of the
the
contract.
option. There
That's
are
correct.
there
Exactly.
are two sides to it. It's not just like, hey, I'll spend $5 on extrinsic value and watch it go to zero. Boo hoo. It's what am I getting for the five
What am I
bucks?
getting for it? Correct. People don't finish the thought. They say, oh, it's going to go to zero. Well, that's true, but what are you getting for it? Pretty much everything goes to zero. Your laptop goes to zero. Why did you buy it? Your cell phone will go to zero. Why did you buy it? See, they don't finish the thought and say, well, what is it that I'm getting?
What am I getting?
So there's our question. Do they decay faster over time? So what do we mean about this? Not just that they go to zero, but what do we mean by decaying faster? Well, we're talking about this idea that traders have that it accelerates. So here's a time decay graph. I did it with 100 days and counting down to zero, there's expiration. We start with an option worth $10. So we know, or at least options traders think, that it doesn't go in a straight line. Kind of starts out fairly flat and then does what? Like Wile E. Coyote right off a cliff. And this is what they're seeing. And they're going, hey, you can't argue it, Stu. I can see it right there with my eyes. It is accelerating. Then they point to some other properties that during the first 75% of the option's life, in other words, 75 days have passed, 25 remain, that option's going to lose 50%. And therefore, in the final 25% of the time, you will lose the second half of that option's value. So if we look at it, we can see that it's 10. Here's 5 would be the halfway point, and that's exactly where we line up. And that's why traders say, look, it's right there, it's black and white, it's obvious. And one of the things that we like to show, we're going to be doing 2 full days of this. These are illusions, and it's very hard to convince your eye that you're not seeing what your eyes are seeing.
Bill, are
People
we
look
going to be are we going to be flipping this to the out of the monies here, or are we going to just reset it?
not today. We're
We're
going to
we're
talk.
going to save that, everyone. Yeah. Okay. Very good.
We'll
Excellent.
talk, yeah, that
Okay.
because that's another good topic.
Yeah.
People
Yeah.
see
Love it.
this and
Yep.
they start to apply it to the out of the money covered calls. No,
Yeah.
whole different ball game.
Wrong. Yep.
Whole different ball game.
Yeah.
But why is this an illusion? And this is the thing that's hard to see. And as we talked about, the things we're going to show you are backed up with math, not, well, somebody told me, and this is how I was taught, or there's a bunch of YouTube videos on it. That's not math. We want to show you, why are we getting this curvature? Why is it bending? Well, it turns out is that if we were to look at the way that options are priced, they're priced according to the square root of time. I think most of you have heard that. If you have a 1 month option that's worth, let's say, $1, a lot of traders think a 2 month option would be worth twice as much time. Nope. 4 times as much time. That 4 month option would be trading for 2. And people say, oh, look, I'm getting a discount. I can buy more time. I'm getting cheaper units of time. It's like shopping at Costco. No, you're getting slower resolution. And so if we were to price these with the square root of time, again, if you have a 4 month option, square root is what? 2. It should be 2 times as much as the 1 month. That's where that's coming from. And there's a very detailed reason. That's kind of one of the foundations of the Black-Scholes model, where that's coming from. But here's the problem. You're casting those values, these square root values, onto something that is what we call a linear line, just 1, 2, 3, 4, 5. Those aren't square roots. They're just counting one by one. It's called call it a linear ruler. And so when you cast a shadow, let's call it, of a square root function or square root series onto a linear ruler, you must get curvature. That's the detail. That's the math that everybody overlooks. Again, traders don't complete the thought. They go, well, there it is. So let's show it here, Stu. Let's do this. Everybody's heard about how money compounds over time. So let's say that we deposit $100 right there, halfway between 0 and 200, and we hold it for 30 years at 10%. What happens? Like a rocket ship, we have, look at that, curvature. And people say, oh, I get it. As you hold through time, the amount of money you're getting accelerates. Well, yes, if we want to compare it per unit of time, but that base is also getting bigger. It's not 100. If it were, it would just be adding $10. It would be a straight line. So see, we're casting this compounding idea onto a linear ruler, and we get curvature. So how could we fix this? See, here's where, as a trader, I could say, look, this is proof that money accelerates over time. It's right there. My eyes can see it. I can say, no, not necessarily. Let's change the ruler to be a square root, or let's go by 1.1. We might call a log ruler. So I'm going to look at 1 day, and then I'm going to look at 1.1 days, and then 2.21 days. Very few people think about time that way, but who says you can't? Why do we have to think of it as 1 day, 2 day, 3 days? So if I do that, what happens to our exponential growth here? Look at that. See, now I could make an argument that money grows at a constant rate. It's really growing at a constant multiplier, but I can make it look like it never changes. And that's true. The rate of multiplying by 1.1 never changes. So see, I can fool the eye into saying money does not explode over time with this curvature. I could make that story just as compelling, but what else could we do? Let's do a flip time decay curve. Let's put a constant 1.1 multiplier and flip this to a square root. Let's look at the square root of time. Now, again, most people don't think of it that way, but nothing says you can't. They're just rulers. Again, you could say it takes you so many miles to drive to Orlando, but I could also measure it in kilometers. It's the same distance. We're just using a different ruler. Same idea here. It doesn't change what's going on. It changes what it looks like.
You could also measure time if you kept everything else constant, couldn't you?
Yep.
That sounds like the model that we use, doesn't
That's
it?
exactly, and that's what we're going to do. I'm going to go with the square root of time. So now we should get kind of the inverse of the square root function. Now what does our compounding function look like? Remember, we just saw that in one graph it accelerated. Another look, it goes straight. What does it do now? That's the same. Those are the same numbers. So now I could make an argument. When you invest, you get explosive move early on, and then it tends to fade out. So in other words, if you're going to invest, do it for a short term, and then reinvest it back here again. You say, well, that makes no sense. But
Right.
That's exactly what traders are doing. See, I could make that argument from this graph. And that is the problem. It is not that they are decaying faster. What a lot of it is, here's kind of a psychological look, is that we're having the same time decay, or at least the same rate, being compressed into smaller units of time. So think about this. Here we have on the Space Coast, let's say we have a shuttle launch. The clock pops up with, let's say, an hour to go. Anybody really excited? Jan, you're going, we got lots of time. People out wandering the grounds, nobody's excited. But what happens when they start when the countdown timer gets to 10? Now everybody's excited. Why? Is the clock ticking faster? No. From 1 hour, 1 second later is exactly the amount of time as from 10 to 9. But in percentage terms, that's a 10% drop. And when we go from 4 to 3, it's a 25% drop, a 33% drop. Finally, you've lost 50% of your time going from 2 seconds to 1 second, and yet it's still 1 second. So this is kind of to show you a simpler version of what's happening when we look at these time decay graphs. Now, here's one of my favorites, Stu. I love this one. We can go to a map of the world and we look at Greenland. And I hear this all the time. People say Greenland is massive compared to the US. Why? I can see it with my eyes. Again, they don't complete the thought, they just go, there it is. In fact, you can see if you could turn it sideways, it would completely dwarf the US. Well, this is a really fun site. It's called thetruesize.com. And so you can type in over here, you might type in Greenland, it'll highlight it. You can take your mouse and click on it and drag it over whichever country. It'll give you all kinds of stats, square miles, population, all kinds of cool stuff. But what people don't realize is, think about it, the earth is round, more or less, think of it like a beach ball. And what are we going to do? We're going to cut that beach ball and try to spread it out flat. And if you think about it, it's not going to lay flat. And yet that's what we've done. We've projected it. There's that key word again. We've projected it onto a flat surface. And when you do that, you're going to get what? Distortions. This is what's called a Mercator projection map. So watch what happens if we click on Greenland and drag it down here. What's this true size? There it is. It's a little over 20%, about a fifth the size of the US. But yet, if you were to ask traders, hey, don't argue with me, I can see it with my eyes, it's bigger, therefore I'm going to take some actions because I can see that's what's happening. No, you cannot. Your eyes are being fooled. All right, so that's another way to understand when we project different scales onto one scale. You have to get distortions. It's a mathematical fact.
Bill, if you have $5 worth of extrinsic value on a 30-day option,
Yep.
how many dollars are going to decay in that 30-day period?
100% of them, 5.
5, right. Okay, everyone. So if we now have $1 left with, say, 3 days, doesn't the same dollar have to decay? It's like there's a lot less dollars left.
That's why we did the countdown. Right, there's just fewer dollars.
There's a lot less dollars. And think about that from the trading side. If you want to define risk as the dollars, which I'm not sure is a good idea, but go ahead. And if you now have $1 on the table, you knew it was going to decay, but it's not $5 or $10. It's now $1. Now, I would say if you're kind of looking at that as, well, that's my risk, which again, I don't think is a good idea, but you can. And if you do, that's a huge benefit. That's got to be a huge benefit to you if you have $1 that you can blow or win with, whatever, on the table, versus $5 or $10 or $15. That has to be good for you if you're looking at that from the risk standpoint. So what is the amount like? Because all right, so now your theta is 30 cents instead of 5 cents. So what? You knew that going in. You knew it was going to compress the amount of dollars into the time.
Right.
And you have a huge benefit from the curvature that may or may not come to fruition. So what's the problem, everyone?
So think about this. If we go back to our time decay graph that we saw, let's say this option's priced at 10 for 100 days. And now we get to the halfway point when it's worth 5 and people go, oh, now I'm on the steep part of the time decay curve. Again, it's an illusion. If you had an option with 25 days, brand new, you just bought it, right? Psychological, you'd be back on this curve with that number being changed to 5. You'd still have those same relationships. But because people anchor to where they bought it, they see that they're getting to the steep part of the curve. So let's go back. Here's the square root pricing relationship, which is true. This is how options behave. But now let's put our scale into the square root time that we saw before. We'd get a straight line. So watch what happens. If I say that my option is worth half, $5, where does that occur? Well, in square root time, at 50% of the time. I'm saying square root of time on this black line. If we do it according to option pricing, we'd say, no, they occur at 25% of the time. But what's the square root of 25? Or square root of 0.25 is a half. It brings you right back to here. See, you're just looking at two different scales. And listen, I know if that's new to, yes, it is it can be an odd thing to try to understand right off the bat. But my point is, our point is that this is why it's so easy to fall into traps. Because the YouTube crowd says, well, look at that. You're heading off on the steep part. Let's go ahead and roll it out. And people go, like. Oh, this is amazing. This guy's a genius. Nope, your eyes are being fooled. Now, why is this a problem, Stu? Because kind of what I just talked about, that people do things for the wrong reason. So let's take a look at this. Go back to our idea of can you hedge theta? You can always find a hedge for uncertainty. That's what options are all about. That's why you have car insurance or house insurance, life insurance. Those are uncertain. You can always find a hedge for it. Always. For a fee, someone will take the other side. The rest is easy, relatively easy. The formula is easy. We find out the probabilities and fair value, and there we go. So if we think that if that's true, if theta is a risk, right, it's uncertain, you should be able to hedge it. So here's another demonstration we're going to do with people. Let's go hedge it. And I'm going to do, let's say, a strawberry. I'm going to put it in a block of ice. And let's say that if the block of ice melts, it's sitting on a counter, room temperature. If the block of ice melts, I'm going to lose my strawberry, which is going to have a $1 value to me. And I'd like to hedge that, Stu. So you're out there making a market. What am I going to have to pay for that? It's going to be a $1 loss. What's the value of that if we know that it's going to happen?
Well, today it's $1, and at the end it's zero.
It's $1 today. So in other words, I have to fully pay for the amount that I'm going to lose. Well, where's the hedge in that? See, and the reason that you can't hedge it is because it's known. You have to pay for it. And that just shows that no, you're not hedging it. You're just paying for it up front. Hey, Stu, I'll give you $1 today if you'll give me a $1 when this ice melts. Well, why is that a hedge?
Can I use my lawnmower cut the guy's grass next door money to hedge this
It's
dollar?
exactly the same idea, right? So what we're saying is that if this is truly a risk, go try to hedge it, and you can't. Now, this is again where traders get into misperceptions, kind of what you were just talking about. Let me go sell an option against it, and now I've hedged theta. No, you have not in the least. You have sold off upside, and you're choosing to take this cash and apply it to something where it shouldn't even be applied. They're illusions, and this is why people make such bad decisions. One last example, because I know this can be tough, but here's what's happening. If we can't hedge theta, what are the options really doing? What they're doing is resolving information. We're going to do a lot of demonstrations with this to show that they actually resolve information. Completely different thought of approaching the markets. We show that they live in this space called information time. They're resolving information over time. It's not price over time, it's information over time. And when you project information on a linear ruler, information is the extrinsic value, you're going to get that curvature. So let's go, let's do your birds and my bucks. Let's say that Stu and I have a bet.
Yeah.
And the first quarter, maybe even early in the first quarter, the score is 0-0, and the birds are about to kick a field goal. Think of it back with our shuttle launch. Is the crowd getting super excited?
Is there any line on this bet, Bill?
We're going to make it straight up. So the thing is that if you could trade in real time, could you sell your ticket for a lot more? Yeah, okay, it's 3 points, but there's still a lot of time. In other words, we don't have a lot of confidence that means that the Eagles are going to win. Now watch this. We're going to go to the final 30 seconds. Score is 21-21, and the birds are about to kick a field goal. Same 3 points. What's the feeling of the crowd? Now you're hearing some excitement. Why? Because your bet's going to either go to 0 or 100%? No. In other words, you should sell it because it's going to decay quickly. See, it's an illusion. You're going to resolve the game instantly. You're going to know in a matter of a couple of seconds whether your ticket is worth its value, the bet, whatever it was, or if it's worth 0.
Think gamma, everyone.
This is exactly the sensation of gamma, where
Yeah.
Stu and I will look at this and go, hey, for what we're trying to do, this would be a great scenario. And people say, no, let me roll it out to a leaps because I don't want it to decay. And you're going, oh my gosh, this is a perfect setup. You just killed it. And this is what traders do every day when they just sit there and chase their tails, these illusions of saying that uh, options decay faster near expiration, and therefore I have to get out. It
So
sounds good until you start digging deeper.
here's my usual disclaimer, everyone. Do it, but do it for the right
For the
reasons.
right reasons,
We are
correct.
not saying don't sell off the tail. We are
No,
not saying don't try and
correct.
cut down your cash flow. We
Yep,
are not saying that. We are saying if you're interested in not paying for the extrinsic value, which I'm kind of wondering why you would have bought it in the first place, but if you're at that point in time, which you can make that decision as a trader, it's okay, it's fine. If you're interested at that moment in time of not paying it, then feel free to go ahead and lay off
sure.
those dollars somewhere else. But
You're doing it for the right
understand
reason.
100% that there's a trade-off for that. And you have to be
Absolutely.
okay with that. And if you're okay with that, have at it.
But
It's all
the trade-off is not I'm hedging theta. That's where people start making bad decisions. So trading decisions, options don't decay faster near expiration. What is it that they do? What's your new perspective? They reveal meaningful information faster. If you have a 2-year option, think back to the football game, you have a 2-year option, the stock jumps up $1.
yeah.
Who
What
cares?
happens to your option? Nothing.
Nothing, nothing. And people go, but the stock is up. Why is my op? Because it's not resolving information faster. Just like the 3-point field goal isn't going to really change the outcome of the game.
Yeah.
But you take that same situation where it's a 1-day option, and you go, how come this one just went delta 1 and I lost all of my extrinsic value? It's the same dollar move. See,
Yeah.
now you understand it's because it's about information over time, not just price over time. So don't base decisions on option values decaying faster. Faster, you are simply mixing apples and
Yeah.
oranges.
Based on what you're trying to do and what you're trying to get.
Right. That's never ever going to lead to a good decision.
Bill, those Micron options last night,
That's a great example.
that call, I'm looking at it right now. That call, that 1050 call went out at $57. Would you say that's like a lot of decay going on, over
It
what's
fully
today,
decayed.
Thursday?
All of
Yeah,
the extrinsic value instantly decayed on that. On that
5,600 bucks on one contract is going to zero just like
0
that.
that fast.
Right.
But people would say, oh, but that's a good thing because we have a lot of intrinsic value. Again, it's mixing apples and oranges. You resolved information favorably.
Yeah, we know what the outcome is. So
We know what
was
the
it a
outcome is, so
problem?
why pay the extrinsic value? Right.
Listen, this is the kind of mindset that you have to have going in. What do you want to do? What are you trying to do? What are you thinking about? What are you trying to get out of this? And are you giving away the very thing that you tried to get in the first
And
place?
that's a very good way to put it. That's what traders end up doing, why they make such bad mistakes. So back to chalk talk. That was a fun one. We kind of come full circle here. Here was our question. Options decay faster near expiration. Again, we now know that's not true, but that's what traders will say. And therefore, you must be careful of holding options near expiration. True or false? What'd you come up with, Stewie?
Dude, I love having options near expiration, so I'm going to go
I,
with
I had the same way. It's big time false. So, what is it that options are doing if they're not decaying over time? They are.
resolving info.
That's the mindset. And those are some of the things we're going to be teaching July 24th and 25th. 2 full days, just Stu and me doing stuff like this, live demonstrations, giving, doing auctions with the crowd out there with our class, live demonstrations to show many of the things that you are trading on are simply illusions. They're mathematically false. And it's going to be a big shift of mindset. So
And
we'd
we're
love
good.
to have you there.
we're going
Stu,
to
any
be
final closing comments here?
yeah, we're going to be using a lot of this is going to a lot of this is theory, and a lot of this is going to be real
Yep,
execution and application.
that's
We're
right.
going to use a real matrix and show you how it works.
We are. How those
Yeah.
where those prices are coming from and how you can be a better trader, not because we have the secret
No,
strategy,
no,
but
no.
because you're making better decisions. So we
That's
hope
right.
that helped for right now. We hope to see you there, and we will see you next week on Coach's Corner, and we'll see you then.